I brought this new ASA filament for my upcoming solar project and I tried to print some parts with this filament, but printing with ASA is not easy as PLA. I was facing the issue as print is not sticking to the bed and the corner wrapping even after printing with raft, and I also tried using masking tape with glue applied, but the result is same. So I decided to make my own enclosure for my Ender 3 Max. This enclosure is based on IKEA Prusa enclosure. Since it is a max size printer, standard IKEA table will be too small, so I made it my own. First I printed the required parts for the enclosure. I scaled and remixed these parts to support 40 mm size legs and 3 mm acrylic sheet. Link to this STL files are available in the video description. To remove the strings, use the lighter or hot air gun. Burn the strings and rub it with your hand to remove the strings completely. I am using the 16 mm plywood for this project. Dimensions are shown below. I completed making these legs on top of the enclosure. Now let's laminate these parts. I'm using the laminate sheet cutter to cut this, and once you made the cut, bend the sheet to separate it. I'm using this quick dry Fevicol Heat-X. Apply on both plywood and laminates. Wait for a few minutes and stick both together. Then it will stick together instantly. I repeated the same steps for all other pieces. I also made this table my own. Here is where I am going to keep my printer and the enclosure. Here are the completed legs and top of the enclosure. I didn't remove the laminate protective cover to prevent any scratches during the installation. The legs are slightly above 40 mm, so I had to trim them to fit into the 3D printed parts. Once trimmed, now it fits perfectly. Now I started installing the 3D printed parts into the wooden parts of enclosure. I install the 3D printed parts in the top cover and legs. Now I install the legs to the top of the cover by inserting the screws. These legs are too heavy since I used thick plywood, so it is not steady. Then I decided to add these metal L-clamps for support. Now the legs are very stable after installing these metal L-clamps. I am making this mark to install the bottom support. I am using this double side tape so it won't be moving while inserting these screws for better accuracy. Now align the legs to the bottom support and place the enclosure top cover. The acrylic sheet is not fitting into the printed parts, so I decided to cut this part and fix the acrylic sheet using the screws. Also printed some additional support for acrylic sheet. Now let's cut this acrylic sheet into the required size. I am using the acrylic sheet cutter for this. Make multiple cuts so it will be easy to bend and cut. Place a wooden board on small area side and bend the large area side so it will be much easier to cut the acrylic sheet. Remove the scratch protection paper and separate the acrylic sheet. Did this marking for drilling the holes in acrylic sheet. For the door, instead of using the glue, I drilled a hole to install the screws. I am using the standard door magnet and a double side tape to fix it. The screw will act as a metal object to stick into the door magnet, which is more than enough for this acrylic door. I printed this for inserting the filament. To fix this, I drilled a hole on top cover. I am going to use this aluminum profile for LED lighting. For this, I am using warm and cool white 12V LED strips. To prevent any short circuit at the end, I added this cap down tape. To control the LED brightness, I brought this LED controllers. This is only for 12V LED strips. For holding the filament, I am going to use the same filament spool holder. I just screwed it into the top of the enclosure. You can get the link of this STL file in my Sprite Extruder video. Check out the link in the description. The power supply needs to be mounted outside the enclosure, so I printed these brackets. Since the heatbed cable will be hitting the acrylic sheet, it is better to bend it into a L shape by using the zip tack. Now we are going to print inside the enclosure, so the temperatures of the nozzle will be too high. So it is always better to have this smoke sensor to prevent any fire accidents. Finally, we have completed the enclosure. Now let's put the printer inside and start printing. Make sure there is enough clearance for the printer pen.